All right, basically we are now into our physics section, and what I want to take a look at is basically how fast things go in free fall. Now, I should say that in freshman science we do not care about air resistance. We just say free fall is no air resistance acting on it. And I should also say that everything that we deal with is always starting from rest. I want to take a look at these two things here. What's the acceleration of a Hummer falling for 2 seconds, and what's the acceleration of a nut falling for 5 seconds? Now, acceleration is v sub f minus v sub I divided by time. The final velocity minus the initial velocity divided by time. Now, for velocity is a speed and a direction. For all of these, we're just assuming straight down because most everything that I've dropped ends up going straight down and buttered side down as well. So the first one, what's the acceleration of a Hummer falling for 2 seconds? I can look down here, and we're not going to get into this video. We're not going to get into how scientists figured out this data. We're just going to say, okay, if something's falling for 2 seconds, it's going 19.6 meters per second. So that would be 19.6 meters per second minus the initial velocity would be 0 meters per second. Don't really need that label, but that's all right. Divided by 2 seconds, we end up with 9.8 meters per second squared would be the acceleration of a Hummer that was falling for 2 seconds. Now we can do the same thing for a nut falling for 5 seconds. It's the exact same formula. This time I'll do it over here. It would be a final velocity if it was going for 5 seconds, 49, so 49 meters per second minus 0 meters per second divided by, in this case it's been falling for 5 seconds. Put that into your handy dandy little calculator, 49 minus 0 divided by 5, you get an acceleration of 9.8 meters per second squared. That means that anything falling, regardless of its mass, now we are neglecting the air resistance, but regardless of its mass, it will accelerate at 9.8 meters per second squared. Another thing that we saw is that this velocity, this initial velocity, we really don't even need it because in free fall it's always always 0. So we can say acceleration equals the final velocity or the velocity divided by the time. Now also notice we can multiply both these sides by t to get velocity equals acceleration times time, how long it's been falling. Now that is, sorry I'm getting a little scrunched here, but the acceleration is always 9.8 meters per second squared, otherwise known as a g. And so scientists just often use v equals g times t. The velocity something's going when it's falling equals g, and g is a constant due to gravity, acceleration due to gravity, which is always 9.8 meters per second squared times how long it's been falling. So v equals g times t. Hope this helps. Thank you.